The objective of this presentation is to explain the design process methodology that we are conducting in Hexa-X-II for establishing the holistic perspective on the 6G end-to-end system, targeting the key 6G performance and also the key 6G value objectives that we have that are environmental, social, economical sustainability. I will briefly go to the different steps we are processing when building this holistic end-to-end system design. And also at the end of my presentation, I will indicate how we can interact more concisely with the Stream B project of SNS. Briefly, we start by looking at the motivation for the 6G end-to-end system and how we can evolve from 5G to 6G. And one of the lessons learned from the migration to 5G is first that we have to limit the number of deployment options. So in 6G, we should focus on the 6G standalone from the beginning. The core network should be enhanced from the 5G core. Both 5G radio access and 6G radio access can be connected to the same core with some enhancement of new or modified components to support 6G. Furthermore, this 6G RAN will support an extended spectrum range and also provide efficient spectrum sharing to be implemented to share with existing 5G spectrum, and that from the first release. Also, the motivation for evolution towards 6G is that 6G is expected to become a platform that provides a wide range of service, not only for telecommunication service, but really for providing a wide range of new services to application, including compute as service, And for that, the network should be able to expose data through simple APIs that are enough abstracted and that allow for interaction with application. And this platform with this interaction with application will also allow to understand and incorporate any insight from the external environment to create a more adaptive system that closely meets the needs of user and society. And this platform is to create value for 6G network. Then moving forward, we have looked at the 6G design principle for the system and also the system requirement. For that, we indeed leverage the result from Hexa-X, and we also revisit design principle to expand it toward this platform objective for 6G targeting the key value. And so we designed 10 principles, basically support and exposure of 6G, service capability, full automation and optimization, flexibility to support different network scenario, and network scalability, resilience and availability, persistent security and privacy, internal interface are cloud optimized, separation and concern of network function, network simplification, and also a minimization of the environmental footprint to enable sustainable network. Also, we looked at 6G requirements, and a preliminary set of these system requirements have been identified in terms of the capability that the system should provide and what the system should do, relevant to a first list of use case that is under investigation in work package 1 of Hexa-X-II. And of course, I won't go into detail for this requirement, but you may have a look after as the slide will be available. Then we also looked not only at the system requirement coming from the use case, but also at a set of requirements related to the operation aspects so this kind of requirements are useful and needed for the operator to provide all the functionality to efficiently fulfill the use case requirements. Now, moving forward to the end-to-end system design, before going into the detail of this system blueprint, I just want to briefly recap some of the terms we are using inside Hexa-X-II. As I already introduced, the 6G platform, this is really the external view from the application perspective, ecosystem, including enterprise, vertical, and so on. This is the external view to create value, and from the set of technology and interface. And the 6G end-to-end system, this is a technical realization of this platform, and it includes enablers that provide all these services. And in Hexa-X-II, we define an enabler as any technical assets that make it possible to realize or enhance the 6G capabilities. And based on all these aspects related to the end-to-end system and the enabler, we will provide a 6G blueprint that is indeed a reference architecture to meet the end-to-end system with respect to the hardware, software, and application. Then, built on those design principles and system requirements, we have designed a first foundation for this 6G blueprint. And indeed, it consists of 4 layers: application layer, network-centric application layer, network function layer, and infrastructure layer. And there is also a set of pervasive functionality that complete the picture, and they are so called because they are indeed spreading across all layers and also spreading inside each layer. The 6G blueprint provides a framework for integrating the new functionality and novel technology, and the different components that are developed within Hexa-X-II and also within other SNS Stream projects will be integrated on the different block of this system blueprint. And of course, I won't go into detail of all enablers that could be integrated in this end-to-end system, but I will much more focus on how we would like to analyze the enabler to check how they can be integrated in the end-to-end system. And the other presentation from Hexa-X-II will give you more detail about some of those enablers. I also want to highlight that this application layer, network-centric application layer, is really to enable a customer and user-centric approach. And it will allow also a full ecosystem of application to interact with underlying platform to a network to leverage QoS, also sensing service, enhanced localization, computer service, and AI services. Going forward now, I want to highlight what is the system design we are running currently in Hexa-X-II with several iterations looking at as more new use case are studied with the KPI and KVI, also revisiting the design principle, revisiting the system requirement, and also consider the set of enablers that are refined and augmented during the lifetime of the project. The iterative system design is indeed towards systemization, and it is about evaluating each enabler, how they can contribute to the end-to-end performance and also have impact on the key value. And basically, we will have 2 sub-processes. The first one is to consider the targeted KPI and KVI, and then elaborate based on from the use case, and then elaborate the needed functionality enabler to provide the 6G design, and then get evaluation from system PoC or simulation, and to estimate the KPI and the KVI, and then to feedback to iteratively improve the 6G design. Of course, it needs to make some trade-off as conformance to certain value, sustainability value will lead to degraded performance. The second sub-process for this design of the system is to have a top-down versus bottom-up alignment, meaning that we will consider pros and cons of each promising enabler and check how it aligns with the end-to-end performance and operation targets and expectation. And of course, this alignment look at different aspects, and we will conduct several analyses for that. And it will also allow to provide some recommendation to refine the design of the enabler, and also to iteratively evaluate the technical achievability towards this end-to-end system design. So we started this analysis by having a first set of key criteria to investigate how the enabler can integrate in the end-to-end system. And basically, it's about how it impacts the design, how it fit with the design principle, how it is feasible and compatible with the migration option we envisage towards 6G, and also all the relationship it has with other enablers and so on. After that, what we already achieved in this first foundation of the system design is that we have analyzed a set of Hexa-X-II enabler in the context of the first system PoCs that we will run that are related to innovation for a use case of cooperating inside an industrial environment. And based on our analysis, we mapped those enablers into the system blueprint. And this is indeed the first iteration we did, focusing on this management and orchestration aspect for the system blueprint. And as the system blueprint represents a holistic view, of course, we cannot use a single picture to depict every aspect of the system. And then we also provide some specific views. Here you can have a look at what is this early view related to management and orchestration. Later in the other Hexa-X-II presentation, you will have more information. And then finally, we've got these 3 system PoC that we are currently running inside Hexa-X-II project, and they indeed provide 3 system PoC with a gradual addition of enabler. Of course, only a subset of all the enablers that are under development in Hexa-X-II, in order to demonstrate the key aspects of the end-to-end 6G system, and also the feasibility to achieve the target in terms of 6G KPI and KVI. And the first system PoC will look at management and orchestration, and we already have preliminary result from this PoC. Then we will integrate enabler related to network architecture, network layer, and flexible topology, and also looking at beyond communication services. And at the last system PoC will also integrate aspects related to device and radio. And also we have some plan to have some end-to-end simulation to complete the system PoC result. So now going fast about how we can have a look at the enabler coming from the other SNS Stream B project and integrate in this overall 6G system. So this is a slide already shown by Miko, so I will move quickly. So we want to apply this system design approach conducted in Hexa-X-II, also integrate the other enabler coming from the different SNS projects to identify any missing or undercover enabler that are important for the 6G platform. Also check and align about the design principle for 6G, and also investigate possible alignment and complete related to some subsystems that could complement Hexa-X-II system architecture to provide this holistic 6G system. That's it from my side. I will stop there and give the floor to the next presenter, who is Raoul and Gyada from Hexa-X-II, to present on enabler for management and orchestration.